In our discussion of Pigeon, I occasionally mentioned how bad operations would trigger what I called errors. And when one of these errors occurs in Pigeon, the whole program basically terminates. In JavaScript and many other languages, these errors are called exceptions. Here, for instance, we have code which multiplies a string times a Boolean value, but this doesn't make any sense at all because multiplication doesn't make any sense with strings or Booleans, let alone strings and Booleans together. So when this expression evaluates, JavaScript will throw an exception. And just like with errors in Pigeon, the exception is going to terminate the program. However, JavaScript gives us a mechanism to intercept the exception, to catch it, and then to handle the exception, that is, to do something appropriate in response to this error. So we don't have to let exceptions crash our program if we don't want them to. Now, it's very important to understand that, say in this example, we've done something obviously wrong in code, and the correct response here is not to stop the exception, but to actually fix the code. The reason we're given the ability to stop exceptions is because in some cases there are some things which might happen which are outside your control. A very common such case is, say, when we deal with files. When you write code that opens a file so as to read or write it, in the course of the reading and writing of that file, there are various things that might go wrong in the system that have nothing to do with your program. For instance, your program might have open a file which is on a flash drive that's plugged into a USB port. The problem is that at any moment the user might yank out that flash drive, and then you'll no longer have access to the file. In that circumstance, you would get an exception in your code which it would be appropriate to actually catch and handle, because that's the sort of error your program might be able to cope with. You wouldn't want your program to terminate just because some file it was using suddenly becomes inaccessible. Instead, your program should cope with the situation somehow. So they're called exceptions because they are errors which are supposed to arise in exceptional circumstances. So despite the fact that this isn't the sort of exception we should be attempting to handle, I will show you how we could. If we put this line of code inside the try block of what's called a try catch, then when the exception occurs, execution jumps to the catch block, and an object containing information about the exception is passed to the catch block. So here, when this try catch block is encountered, execution enters the try block and it starts executing through the statements. But in our first statement here, an exception is thrown, so execution jumps over the rest of the try and goes directly to the catch block. And in the catch block, the exception object, the object with the information about the exception, is passed to the variable in the parentheses after the word catch. So here it's passed to the variable ex. And so our catch block executes, and presumably we do something which somehow copes with the situation. It copes with the eventuality of this error. And finally, once the whole catch block has executed, execution continues on beyond the whole try catch. So one source of exceptions in JavaScript is when we do a bad operation like attempting to multiply a string times a Boolean. But another potential source is when we ourselves actually create an exception using a throw statement. So what happens here is that again execution enters the try block, and the first thing in that try block is we throw an exception. And the exception object here is the string reading "we're screwed." So execution jumps down to the catch block, and the string "we're screwed" is passed to the variable ex. So I'm sure you're wondering why you would possibly want to actually create your own exceptions. And part of the answer is that obviously in this case you wouldn't. In particular, what you wouldn't do is what we do here, where we generate the exception inside a try and then immediately catch it in its corresponding catch. Instead, what we would do is we'd throw the exception, but then we'd allow the exception to propagate outside of the function in which it was thrown. An exception which is not in a try block propagates outside of the function in which it occurs. And here's what that means. Say we have a function foo which itself throws an exception for some reason, but does not itself catch that exception. Consequently, where we call foo, we are effectively throwing the exception in that place. So if we call foo inside a try block, that try block is going to catch the exception that propagates out of foo. So when that happens here, execution jumps down to the catch block with the exception object passed to the variable ex. So the key idea here is that when an exception occurs in a function but then is not caught in that function, the exception will propagate out of that call to where the function was called. If the exception is not caught there, it will continue to propagate, and eventually, if it keeps propagating, it's going to propagate out of all the functions to the global level of code, and finally, if not caught there, it's going to terminate the program. Though actually I should say JavaScript implementations in web browsers actually just usually ignore such exceptions. Execution simply continues on. In any case, here's an example, and let's say we still have our function foo, which throws an exception. Well, here in the function bar, the first time we call foo, we do so in a try block, so it's caught and handled, but then we call foo again outside of any try, and so an exception is going to propagate out of the call to bar. It's quite tricky to learn when it's appropriate to throw your own exceptions and when it's appropriate to handle exceptions. In truth, you probably won't be dealing with exceptions at all in JavaScript, especially if you stick to writing JavaScript for the web browser.